considering that the 0 point of time was always in the position of the observer looking at the sky at night, and that, to see a distant star, was dependent on the local scattering of the light it emitted. That light would not have to have moved in space at an earlier time. In fact, the light of the star would always have been with us. It is as if the light were ubiquitous and had been everywhere else in space before its spreading. If we agree with the statement that space would not have the power to directly communicate the events in which it was involved, whether at the atomic level or in the macrostructure, that space would become a phantom entity. This is what the light cone of the future of events suggests to us. We see Beta Andromeda 75 years late. If I were the space and wanted to communicate with a spectator, I would need to do it indirectly or through a messenger. In the case of distant stars, the time spent by their messenger from there to Earth could not be directly measured, since it would only be possible to evaluate it by remote tracking of the light, or in the direction of our past. Although this space was a fictitious entity, for the observer's point of view, it could still maintain a continuum over time. The condition would be the time was linked to the relative movement assumed by the light in our past. Since, before that, there would be no measurable time, we would need to start the search for the quasis that would be holding time in our future. One of them would be the necessary quantization of light, or its packaging in the form of a photon. The similarity of this process to the cone of light of the future is that it would not take time. When it comes to astronomical distances, there is no other way to measure time that does not depend on visible light or the spread of some other form of electromagnetic radiation. When the scattering of the photon happens, the sources of light already appear in our past. The difference of this alternative view, in relation to the continuum model proposed by the theory of relativity, would be supported by the observer's point of view. It would not necessarily have to be linked to the reality of the universe. That is, the universe is not very concerned with what we think about it. The problem is our dependence on the space messenger, the light, which has elusive behavior. In the case of the cone of light of the future of a star, or of a black hole, the light would always place space itself in our future, or on the other side of what can be observed. In the visible universe, we are used to measuring time by the limited speed of light. This would refer to Einstein's claim about the independent capacity of space to generate inertia, independently of the masses. By acting independently on the masses of stars, space could promote the relative movement between them, resulting in changes in their densities. This would be reflected in a veiled variation of the curvature of space around the star masses, leaving space in obscurantism. the space would also act in a hidden and ghostly way in the inflationary phase. If there was not an inversion in the direction of the arrow of time next to us, and that would allow us to measure time through the scattered light, there would not be an inflationary phase that could be remembered. The relativity continuum tells us that, starting from certain limits of space expansion, there would be a contraction of time at subliminal levels. Inflation would act like an immense information eraser, even if it were still there. This also happens at the subatomic level. What can be remembered by us would be linked to the direct measurability of time and would remain on the opposite side to that occupied by space. That is, on the inside. When a quantum hits a free electron and spreads, you see the particle instantly inside spacetime, but outside its real position. According to Iceberg, the uncertainty of the particle's position would be linked to the necessary quantization of light used to see the electron after its scattering. Although quantization does not take time, it seems that the particle is seen late or outside its true position. Time would not exist, or could not be gauged directly, within the cone of light of the future of any massive event, as is the case with a star. At this moment, I came to believe that our subjective assessment would no longer depend on the distances that light could have traveled in space before its scattering. This time could only be evaluated indirectly by the scattered light after previous packaging. As nothing can be described directly by space, or depends on its messenger, the universe could be unified at all levels by our observation. So, I was lagged by light to see what happens to it at the subatomic level of matter being introduced to a process known as quantizing light. All measurable forms of energy are quantized. Because we are dependent on the scattering of the quantum of light to see the subatomic particles and, likewise, to see the distant stars, I saw that there would be the possibility of removing this temporal barrier that separates the two structures. No one else could contest me by saying that quantization is a matter of the microscopic universe and not of the macrostructure, since these worlds depend on the same type of remote light tracking. Or, ultimately, they depend on our point of view. The most relevant fact is that the packaging of light or its quantization does not take time, as demonstrated by the first time by Both Geiger in 1925. When we put ourselves in dependence on the messenger to describe the changes in the geometry of the sending space, we concluded that only cosmic background radiation and time could be part of the continuum. The space would be left out. This suggests that we are, in fact, slaves to cosmic background radiation. One of the scams it provides is the concept of continuous waves. That is, after scattering, the light would amend its wavelengths, even though it is known that the previous quantization of the light suggests the discontinuity of the electromagnetic waves. Continuous waves are directly linked to the length of time. This misconception is that it would allow us to use light to indirectly measure distances and speeds, as well as the time that would separate us from distant stars.